This is what 761 horsepower sound like in the Porsche of the future. It's quiet, but it certainly does not hold back. It takes less than 3 seconds to accelerate from 0 to 100 kilometers per hour. And above all, it doesn't need a single drop of gasoline.
The sheer explosion of power, this precision with which you drive the vehicle into a curve.
Its name, Taycan, stands for the wild spirit of a young horse. With it, the company intends to shoot to the pinnacle of electromobility.
The car drives like a dream.
Porsche's new 4.0 plant cost around 700 million euros. Consisting of humans and high-tech robots, the team working here is completely networked.
The challenges posed by the Taycan are far greater than for a vehicle with a combustion engine.
As a fundamentally new design, this dream car from the German sports car manufacturer took 4 years to develop. This is the bundle of energy from Stuttgart, the Porsche Taycan. Porsche's main plant is located in the heart of Zuffenhausen. Covering an area of 614,000 square meters, it's the birthplace of some of the most iconic sports cars in the world. The Swabians have built a completely new factory at the plant premises for their new prestige model, the Porsche Taycan.
A mammoth project has been implemented, the most radical change in the site's 70-year history. We've built a factory within the factory, and did so while series production of the two-door Carrera, Cayman, and Boxster sports cars were running. It's like getting changed inside a wardrobe. So we've accomplished a huge achievement here in the past few years.
The new, roughly 14,000 square meter assembly shop for the Taycan has been built in this wardrobe. What it contains is pure high-tech. Gigantic elevators link the assembly lines to one another. Because the production lines extend over 3 floors of the 38-meter-high building. To overcome the challenge of 3-story production, 300 employees and numerous autonomous transport systems make sure that everything runs smoothly. There is no classic conveyor belt here. The electric handling robots transport the individual components from station to station. It's teeming with intelligent systems and state-of-the-art machines. The top version of the Taycan, the Turbo S, offers a whopping 761 horsepower on the road. From a standing start, it catapults to 100 kilometers per hour in 2.8 seconds, with a curb weight of 2.3 tons. The electric sports car is powered by a rechargeable battery with an 800-volt onboard electrical system. The vehicle is automatically governed to 260 kilometers per hour. An automated guided vehicle system, shortened to AGV, is on its way to the first station. The battery-powered high-tech worker uses a QR code strip on the shop floor to navigate. It's in permanent contact with the logistics software via Wi-Fi. For the next 14 stations, the AGV is the assembly platform for the freshly painted Porsche body shell, like this light blue one. The difference between the Taycan and sports cars from the majority of other manufacturers becomes apparent at the very first station. Instead of a fuel filler neck, it's fitted with a socket. The electric sports cars that are manufactured here are built to order for customers around the world. This is why the workers fit different connections on the vehicle. They are located on both sides, just above the wheel arch. The orange color of these cables officially identifies all high-voltage connections. The transport robots never stand still throughout the entire production process. This AGV is chauffeuring a black body shell to the next station. All Taycan skeletons are produced in a single building at the plant premises. The body construction department is located in Plant 5, Building 30. This is where the new sports car starts its journey. The body shell undergoes a fully automated production process involving classic robot ballet. The body shell's base frame moves to the first automatic station on the production line. This is where the framework is given both of its side elements. A robot takes the component for the driver's side to a bonding station. This high-tech colleague then applies the blue assembly adhesive. The robot then rotates around its own axis and places the component onto the frame. The two side sections are crucial to the body's stability because they consist primarily of hot-formed steel. It can have thinner dimensions while offering the same stiffness, and that saves weight. The darker components each weigh 45 kilos. They now form the vehicle's A, B, and C pillars. At the next station, the robots weld the freshly bonded side element firmly in place. They additionally rivet and bolt it. These measuring arms come into play after each operation step. Here, robots check the work of robots. If they give their green light, the Taycan framework proceeds to the next station. Porsche manufactures the body shell in a composite design. It's made of increased strength, particularly tough steel and aluminum. With a weight of 180 kilograms, the fully galvanized vehicle carcass fits perfectly into the Taycan's lightweight design concept. To reach the next production step, the emerging Taycan has to embark on a short journey. The body proceeds to the next station via belt conveyors and intermediate floors such as these. The next component is one of the most important in terms of the design DNA of a Porsche. It lends the Taycan its unmistakable line.
This component is so important to the lines of a Porsche, simply because we use it to define the fly line of our vehicles. The vehicles take on the typical traits of a Porsche there. Although it's 3 meters long, the component is very light. It weighs 7 kilos max. What's special about it is that we practically start with a normal metal sheet. This sheet is then deep drawn. By that, we produce the entire contour using a drawing tool and are actually approaching the critical limits of what is technically feasible for the components.
A metal sheet can only be deep drawn to a certain dimension. Otherwise, it tears. One final control station and a new, raw sports car leaves the robot line and moves up one floor on the elevator. With its detachable parts, the body shell now weighs around 300 kilos. It doesn't stay that way, though. Thanks to the 650-kilo battery pack, the finished Taycan weighs a hefty 2.3 tons. But that doesn't affect the vehicle's dynamics. Quite the opposite. The battery is fitted in the floor, thus giving the Porsche a very low center of gravity. Thanks to this, it's extremely stable on the road later on.
Our customers sometimes drive a bit faster, and good aerodynamics, a good drag coefficient, are then absolutely crucial. Lots and lots of attention to detail have been packed into it, also in close cooperation between our designers and our aerodynamics experts. They often had to reach a compromise in even the smallest details. The best trade-off between it looks great, but it has the best aerodynamic properties.
The Taycan is not only extremely sporty, it also has to be range efficient. This presents developers with new challenges, especially where electric vehicles are concerned. The Porsche engineers optimized the Taycan in more than 1,500 hours in the wind tunnel. The drag coefficient indicates how streamlined a vehicle is. The principle here is the lower, the better. The Taycan has a drag coefficient of 0.22, so it's up there with the best in the wind tunnel. What are called the air curtains, the vehicle air intakes on the fender, are therefore not only a new Porsche design feature, but additionally improve the aerodynamics. Thanks to their closed form, the Taycan's wheels are also extra aerodynamic to enable a longer range. Whether energy saving or high speed, the intelligent rear spoiler automatically adapts to the desired drive mode. In the body assembly department, the remaining aluminum elements, such as doors and fenders, are mounted on the vehicle skeleton. This front passenger door weighs around 10 kilos. The crew uses hydraulic crane arms to attach it. All moving parts are fitted by workers made of flesh and blood. They have a better sense of shapes and lines than the robots. "37% of the Taycan frame's paneling consist of lightweight aluminum. Accordingly, these technicians can install the 8-kilo front cover by hand. In theory, the front cover is nothing more than an engine hood. However, this term certainly doesn't apply to Porsche's electric sports car. At the rear end, 2 employees bolt on the hinges for the trunk lid. An assembly template makes it easier to install the lid precisely. The workers have exactly 11 minutes for complete assembly. Finally, they check the gap dimensions. Once the Taycan framework is fully assembled, the gigantic elevator transports the body shell, which now weighs 380 kilos, into the painting booth. Porsche has set up the new paint shop specifically for the 4-seater. Here, the vehicle skeleton runs through a 5-stage painting process. It starts with a cathodic dip bath. The paint in the bath is positively charged, whereas the body shell is negatively grounded. When the body is immersed, the paint and metal attract one another statically. This procedure enables all of the components to be covered with a uniform layer of paint, which is only 20 micrometers thick, half as thick as a human hair. The base coat, the color layer, then follows. Robots apply the paint fully automatically. There are no restrictions here for the customer. Any color is possible. After being finally sealed with a clear coat, the Taycan body shell is now 5.8 kilos heavier than before, following a 5-hour procedure. At the end, the robot's work is checked by humans. Very special conditions apply to the employees at this station.
To ensure perfect paint adhesion, we pay attention to whether skin creams used by employees are compatible with the paint. And they don't use hairspray or deodorant containing substances that could attack the paint. Even a lipstick can lead to paint failure. So all the substances that the employees use on their bodies are tested accordingly.
This 911-meter-long corridor connects the paint shop to the main assembly department. A belt now transports the freshly painted body shell to the production line. On the 3rd floor of the plant, the Taycan first receives its wiring harness. Two employees have 20 minutes to install the 35-kilo loom. It's sheathed in a protective cover so that no plug connections tear off when it's rooted in the vehicle. Later on, this network of cables supplies all of the control units and sensors as well as the audio system with electricity. Special frames now move down to the assembly line from the ceiling. The autonomous transport robot takes the body to a rotating cage and then returns to the first station. Because the next jobs on the body shell take place from the outside. The frame with the body shell rotates so that the mechanics at the next station can work comfortably on the underbody of the Taycan.
When selecting our workshop equipment, we particularly focused on ergonomics for the employees. So that work doesn't have to be carried out overhead, but that we can rotate the body shell to the employee instead, so that he can work easily, so that we can compensate heights, and so that everything flows and the employee can do this for 7 hours a day in the least tiring way possible.
Once the workers have fitted the lines for the brake fluid and other operating fluids on the underbody, the AGV collects the body shell again. The new high-tech factory cost around 700 million euros to build. The autonomous transport systems offer a crucial advantage in comparison with classic production involving a rigid assembly line. The production lines can be adapted flexibly to new production processes in the future. This robot is now inserting a panoramic roof into the Taycan body shell. The signal indicates that it's time to move on. In the plant, machines are particularly used at stations where large components have to be fitted. Like the dashboard, for example. An AGV automatically delivers the module to the corresponding location in the plant at the appropriate point in time. Depending on equipment and material, the instrument panel weighs between 60 and 70 kilograms. The employees use a special handling device to install the component precisely and without any damage. After just 7 minutes, the Taycan's control center is fitted in the cockpit. At the next station, the Porsche is given its glazing. To do this, an employee positions the windshield in an automatic station. The glass has to be seated precisely because it contains sensitive sensors for the Taycan's driver assistance systems. The robot now applies a single component adhesive with an added hardener. UV light activates the hardener and ensures a stable bond. Once the robot has also installed the rear window, the vehicle leaves the automatic station. Further along the line, this body shell is now moving down one floor in another gigantic elevator. The second floor houses the second part of the production line. An important operation now awaits the electric sports car: the marriage. This is what car manufacturers call the joining of the powertrain and the body. The floor assembly with the two electric motors, the battery, and the axles is produced on a 30-meter-long pre-assembly line called chassis setup in the plant. In 100 minutes, the technicians assemble a complete powertrain here. It all starts with an empty assembly carriage. The heavy load elevator delivers the front and rear axle assemblies. The workers use hydraulic lifting cranes to place the 150-kilogram components precisely into the carriage. The pre-assembly crew has equipped both axles with a brake system, shock absorbers, sports suspension, and one electric motor each. The electric drive is also produced on its own line in the plant. In this building, 170 employees fabricate the Taycan's rear motor and its slightly smaller front motor in parallel. Here, an electric drive is created in 3 hours at 10 stations. The employees use a mobile work stand like this as an assembly platform for a new motor. All of the parts needed for construction are already stored on it. A 35-kilo copper coil, a rotor fitted with permanent magnets, and a power inverter, called a commutator in technical jargon. At the first station, a worker clamps the drive housing into a machine. It inserts a sealing ring into the steel drum. The parts have to be seated precisely in one another. The gap between the components may only be 25/100ths of a millimeter. The technician then places the motor housing onto the work stand and bolts it firmly to the assembly platform. One of the technically most complicated processes takes place right at the start. Inserting the rotor into the copper coil, the stator. Together, these form the core element of each electric motor. A mechanic now uses a special lifting construction to transport the movable rotor to a further machine. This is where the permanent magnets are prepared for assembly. They have to be inserted evenly in the copper coil. The employee now moves the stator into position at the automatic station so that a robot can grip it easily. He then fits another sealing ring on the steel drum. The Porsche developers call the process that takes place here joining.
Here you can see the rotor and stator, two really heavy components. They weigh around 35 kilos. Both components have to be fixed very rigidly in position when they're joined. The rotor is fitted with extremely powerful permanent magnets. The rotor constantly wants to deflect to hit against the stator. Both have to be fixed in position really well when they're joined. That's why we have this big, heavy system that secures these components as firmly as possible and offers this high joining precision, so that the two components don't damage one another.
The joining takes place in a high-security booth that employees are not permitted to enter during the process. A robot first fixes the stator in place on an assembly station. It's then joined by further motor components, such as the housing and the rotor. Later on, the electric motor transforms electrical energy into movement. So it acts like a bicycle dynamo, but in reverse. Put very simply, it uses a magnetic field to set the internal rotor in motion. This is in turn connected to the vehicle axle. This is how it works. The Taycan's battery conducts current to the copper coil, the stator. It contains the movable rotor, which contains the permanent magnets. So when the coil is supplied with electricity, both generate a repelling magnetic field. This produces a rotary pulse that can be used as propulsion. The power output of an electric motor increases along with the amount of copper installed in the coil, also called the filling factor. Instead of the classic round wire winding, the Swabians have used an angular hairpin-shaped design that allows them to fill 70% of the coil with copper rather than 45%.
This improves the filling factor of the copper, enabling us to insert far more copper in a tight space. This offers higher efficiency, better heat dissipation, and therefore more reproducible performance, but also a significantly increased range.
The Taycan's electric drive is the pinnacle of 21st century engineering skill. Generally, however, the electric motor can look back at a somewhat longer tradition in Zuffenhausen. Porsche fans can take a look at the complete history and marvel at numerous sports car treasures in the company's own museum. Around 90 years ago, not far from here, Ferdinand Porsche began to realize his dreams of designing his own vehicles. Since then, his name has stood for some of the most iconic cars in automotive history. Alongside famous Porsche classics, one exhibit particularly stands out. An antique coach, which Ferdinand Porsche worked on around 30 years before founding his own company.
What's exciting about Porsche is that our history began electrically. Ferdinand Porsche was interested in electromobility, and one of the first vehicles that he developed was the Egger Lohner C2 in 1898.
Equipped with an electric motor from the Austrian manufacturer Egger and simple batteries, the Porsche P1 model had an output of 5 horsepower. It had a top speed of up to 35 kilometers per hour. Even then, this gave the electric coach a range of 80 kilometers. Nevertheless, the following decades were dominated by the combustion engine. Porsche only delved back into the world of electricity again at the start of the 21st century, with its hybrid series and race cars. The 919 Hybrid Evo is a class of its own. Right away, it achieved the best lap time in Spa and on the world's most dangerous racetrack, the Nordschleife of the Nürburgring. The engineers used its technology as an inspiration for the Taycan. Back in the motor production department. At this production line station, the employees are fitting the motor with an unremarkable but important component: the power inverter. It converts the direct current from the battery into alternating current for the motor. The power inverter also regulates the frequency of the rotating field in the stator, and therefore the rotational speed of the motor. The rear axle motor is fully assembled after 3 hours. An employee transports the drive to an automated guided vehicle system using a handling device. Before the workers can fit a new motor with an output of up to 335 kilowatts in the Taycan, it first has to undergo a test. End-of-line test. The test bench really puts the motor through its paces. In a moment, the electric drive will be subjected to 16,000 RPM and a wheel torque of 8,000 Newton meters.
This big grey box is also an electric motor that simulates driving resistance. This means that we simulate the outputs, we simulate the wheels, so to speak, and the major driving resistances that occur at 200 kilometers per hour, such as air drag or driving uphill, for instance. To do that, this big electric motor brakes our drive. And we can test whether our drive, that we subsequently install in a Taycan, offers the corresponding power output.
Test passed. This motor will soon breathe life into a new electric sports car. The Taycan is the first production vehicle with an 800-volt onboard power supply instead of the previously usual 400 volts. The engineers have developed all of the electrical components from scratch. The result is faster charging times, better thermal management, and over 30 kilograms less weight. This is made possible by the considerably slimmer cables. The higher voltage of 800 volts means that the vehicle's electrical system requires a lower amperage and therefore thinner cables to generate the same power. The Taycan has four-wheel drive and is fitted with 2 electric motors. These are mounted on the vehicle's front and rear axles. A gigantic battery pack with a voltage of 800 volts provides the motors with an output of up to 761 horsepower and 1,050 Newton-meters of torque. An AGV is now bringing a battery pack to the pre-assembly area. It consists of 396 individual cells, which will supply the Porsche with vital energy later on. One tank filling is a maximum of 93 kilowatt hours. That's the same amount of electricity as a family of 4 consumes in 1 week. A technician now uses a crane to position the 650-kilogram component over the assembly carriage. The battery's aluminum frame not only holds the rechargeable battery together, it also stabilizes the Taycan's body at the same time. After installation, the team connects all of the high-voltage components together. Later on, electricity will flow through the orange cables from the charging station to the battery cells. 270 kilowatts are required to fully charge the entire battery pack in 25 minutes. That's the same amount of power needed to operate 270 washing machines. The powertrain now moves into a high-security booth. A sensitive step takes place here: the marriage, or the coupling of the chassis and body. At Porsche, this step is undertaken by an automatic station. To do that, this lifting platform moves the floor assembly precisely beneath the vehicle's superstructure's bolt holes. After 3 minutes, the first step of the operation has been completed successfully.
This is where the vehicle's heart is implanted, so this is where the life that subsequently makes it attractive on the road is breathed into the car. And this is not just any heart, of course. This is a Porsche heart. This requires really tight tolerances. The systems have to be set up for this, to complete this fully automated marriage correctly. So we have over 50 bolted connections that are fastened fully automatically to join these two parts.
Directly after the marriage, the workers bolt the moving parts such as the wheel suspension and the shock absorbers. These are still held in place solely by the assembly carriage. Only now can this be released from the underbody. The Taycan is now fully married and makes its way to final assembly. A few stations further on, assembly of the front and rear aprons is on the agenda. The front apron is made of plastic and weighs 5 kilograms. When screwing it in place, the team constantly checks the gap dimensions. Weighing in at 6 kilos, the rear apron is also part of the Taycan's lightweight design concept. Assembling the tail lamps requires particular finesse, because the lamp's red LED strips have to be aligned precisely with the light strips in the trunk lid. The Taycan has a luggage compartment at the front and rear, with a total cargo volume of around 445 liters. At the next station, the electric Porsche is now given its operating fluids. These black hoses are used to fill it with power steering fluid, brake fluid, coolant, and washer fluid. The tires are also crucial to the performance of a super sports car. Only the right blend of rubber transfers the enormous 761 horsepower optimally onto the asphalt. The Turbo S is fitted with mixed tires on 21-inch aluminum wheels. At 305 millimeters, the rear wheels are slightly wider than the front wheels. That improves cornering stability. The 5 wheel nuts are tightened to a torque of 130 Newton-meters to cope with the enormous forces. The men then move the seats into position using a hydraulic assembly arm. Whether they choose leather or synthetic fabric, every customer decides precisely how the interior will look. An increasing number of buyers want interior equipment that is completely free of leather. The Taycan is therefore also available in completely vegan form. Each part of the interior equipment is stored in the system. The computer now releases the steering wheel for assembly along with the airbag.
This means that throughout the entire factory process, the factory system communicates with the vehicle and with the employee. The interface that we need for this is an electronic vehicle card, which you can see on the right next to me. This provides the employee with information on how the vehicle is to be assembled. But there are also a lot of processes running in the background. This means that information is loaded into the vehicle via the factory system and then accordingly via the radio module that you can see here in the vehicle. Here, for example, we're fitting the steering wheel and the steering wheel function, the multi-functions for radio adjustment, volume up, volume down, answering the telephone. They are accordingly loaded into the vehicle.
The plant's internal Wi-Fi system transfers the software for the steering wheel. Throughout final assembly, the sports car body shell is underway without its 4 doors. This makes it easier for the employees to access and work in the interior. The doors are pre-assembled separately on the top floor. That includes the installation of airbags, electronics, and outside mirrors. The complex elevator and rail system in the false ceiling deliver the doors directly to the assembly line exactly when they are needed. The final few meters of the Taycan assembly line are approaching. All that the supercar is now lacking is its badge. This emblem has been proudly displayed on the hood of every Porsche since the early 50s. The worker uses an assembly aid to fix the badge in place on the front cover and bolts it to the hood from below. The rearing horse in the logo represents the city of Stuttgart. The antlers symbolize the federal state of Baden-Württemberg. Just a few meters further on, things take a serious turn.
This is a very special station, the last belt section of vehicle manufacturing. This is where high-voltage commissioning takes place. That means the Taycan comes to life here for the first time.
What sounds complicated only takes a quick click. The employee closes the service disconnect switch. All of the system components are then energized. Electricity now flows through the Taycan's organs for the very first time.
Of course, it's different when I start up a combustion engine for the first time. You get acoustic feedback, maybe even goosebumps. But I also get goosebumps here, because everyone who works here is passionate about this vehicle. And if high-voltage commissioning works at this point, the feeling is similar. I can't hear it, but I know about it, and I may get goosebumps just the same, and say that the vehicle has now come to life.
The living electric sports car now moves into another heavy-load elevator. Its destination is the first floor of the production plant. Complex quality checks await the vehicle there. The fully automated logistics system distributes the vehicles onto 2 conveyor belts. On the first floor, a crew of specialists is waiting to put every sports car through its paces. It now has to run through various checkpoints before it can be delivered. The new owners of the electric supercar expect top quality made in Germany.
Quality means unreservedly meeting our customers' expectations. Our customers' expectations for our products are justifiably very high. The challenges posed by the Taycan are far greater than for a vehicle with a combustion engine. For example, the otherwise so dominant sound source that we like to call the emotional quality, which is caused by our combustion engines, is no longer present in a Taycan. That means they have to establish a new type of emotional quality, and ultimately all kinds of background noises that weren't audible at all with a combustion engine become more noticeable. They move into the foreground. The air conditioning and seat climate control systems, for example, tire rolling noises, and also wind noises. All of these have to be significantly reduced.
And that is precisely what is checked on the wind noise test bench. This employee fastens special microphones to all 4 doors. The booth functions like a dryer in an automatic car wash. The blowers on the left and right simulate air streams that occur at speeds between 120 and 160 kilometers per hour. If a joint is not tight or a window does not close properly, it would be heard clearly, and a technician would have to readjust it. But not only the airstream influences the interior acoustics, the road surface can also produce disturbing noises. The roller dynamometer simulates 3 different road surfaces: asphalt, cobblestones, and potholes. Processing flaws or loose parts would now be clearly audible in the interior. Before the first Taycan rolled off the line in September 2019 in Zuffenhausen, Porsche's newcomer was subjected to innumerable endurance tests during its 4-year development phase. The engineers tested each millimeter of the sports car for maximum performance under diverse conditions.
We had to test the vehicle like all of our vehicles under all of the climatic conditions on Earth, from the lowest possible temperatures to maximum heat, from the polar circle to the desert.
Priced at around 185,000 euros, the sports car had to demonstrate the function of its safety systems in various crash tests. Despite extreme deformation, no voltage is ever permitted to flow through the body after a frontal crash. Electric vehicles pose a particular challenge in this regard. Besides classic safety aspects, the focus here is mainly on the high voltage system and the battery unit. All electronic components have to be specially protected and must immediately shut off automatically if it comes to the worst. On Porsche's Hydropulsar, the engineers have taken the body to its limits. The endurance test bench simulates maximum stresses over thousands of kilometers on diverse terrains. This is how the developers check the static body shell's resistance to physical shocks, also called torsional stiffness. The Nardo high-speed test track in southern Italy. During an endurance test, the design engineers proved that the Taycan can not only sprint, it's also an outstanding long-distance runner. In 24 hours, it covers more than 3,400 kilometers at an average speed of 200 kilometers per hour. Throughout its entire development period, the Taycan covers around 6 million test kilometers. On a track in northern Sweden, the engineers test the vehicle's suspension and thermal management at extreme temperatures, as low as -35 degrees Celsius. In extensive drifts on the circular track, the drivers check the interaction of all the control systems in the suspension. This enables them to precisely adjust the four-wheel drive management system. Reproducible performance is of primary importance to the developers. This means that the Taycan must be able to deliver the same acceleration values on snow and ice as on dry asphalt. In 9.8 seconds, the electric Porsche passes the 200 km/h mark. The developers also test the vehicle's thermal management under these harsh conditions. The interior heating has to remain easily controllable even at sub-zero temperatures. The low temperatures are not permitted to affect the battery capacity or the charging time of 20 minutes. Three final quality tests now await the new Taycan in Stuttgart, Zuffenhausen. This laser is used to align and adjust the suspension for the first time. Later, the air suspension adapts to the road surface depending on road position and drive mode. At maximum speed, it automatically lowers by up to 22 millimeters and therefore improves the Taycan's aerodynamics. The Porsche has numerous driver assistance systems on board. This patterned wall is used to calibrate the front camera in the inside rear-view mirror. The quality crew also checks the position of the headlamps and adjusts it accordingly if necessary. The final test is all that separates the sports car from freedom. The vehicle leak testing facility is similar to a classic automatic car wash. But there's no cleaning involved here. All of the Taycan's components have to be absolutely watertight. After this shower, absolutely no moisture is permitted in the interior. This is immediately checked by the team. Once they have checked the luggage compartment, the men also make sure that lower-lying segments beneath the paneling have remained dry. After a Taycan has passed all of these tests, it drives into an enormous light tunnel. The inspectors here have the final say in terms of quality. They check more than 500 visible characteristics for flawlessness and perfection. They manually check the finish of the components and the vehicle's gap dimensions. They also check whether all of the optional equipment that has been ordered is fitted and good to go. Once the employees have ticked off all of the points on their list, the new Porsche is allowed to leave the plant. The new owner of this Taycan is waiting for his new car in the United States. The Swabians cover some of the components with a protective film for the long journey. The Taycan then sets off on its way. A production story draws to a close. The dream car leaves its home in Zuffenhausen. The Porsche Taycan Turbo S, the Stuttgart vehicle manufacturer, aims to present it as a new leader in the electric sports car segment. The developers and mechanics in the new 4.0 plant do their very best to make exactly that possible. With know-how drawn from over 90 years of automotive history, the Taycan is optimally prepared for the electric future of the automobile.